Sudani, Assistant Professor at LJ Institute of Engineering and Technology. Today, in partial derivative, I will teach you higher order partial derivatives. So, what is the meaning of higher order partial derivative? The derivative of order 2 or more is called higher order partial derivatives. Partial derivatives of higher order of a function u equals to function of xy are obtained by partial differentiation of first order partial derivatives. Thus, if u equals to function of xy, then del square u by del x square, that is equals to del by del x of del u by del x. So this is second order partial derivative. This is partial derivative of u with respect to x. This is called second order partial derivative. Now similarly, del square u by del y del x. This is nothing but the partial derivative of del u by del x with respect to y. This is again a partial derivative of order 2. Now similarly, del square u by del y square, that is del by del y of del u by del y, that is partial derivative of del u by del y with respect to y. So this is again a second order partial derivative. Now similarly, del square u by del x del y, that is nothing but partial derivative of del u by del y with respect to x. Now we will see what is mixed derivative theorem. If u equals to function of xy possesses continuous second order partial derivatives, that is del square u by del x del y and del square u by del y del x, then del square u by del x del y, that is equals to del square u by del y del x. That is, if you will first find out the partial derivative of u with respect to y, that is del u by del y, and then after you will differentiate it with respect to x. And secondly, if you will find out the partial derivative of del u by del x with respect to y, right? So both the result will be same. So this is called mixed derivative theorem. This is also called commutative property. Now standard rules for derivative of sum, difference, product and quotient are also applicable for partial derivatives. Now we will see examples related to this topic. Example number 1 is, if u equals to x square y plus y square z plus z square x, then find the values of del u by del x plus del u by del y plus del u by del z and del square u by del x square plus del square u by del y square plus del square u by del z square. Now u is given to us, that is x square y plus y square z plus z square x. Now first of all we will find out del u by del x, that is partial derivative of u with respect to x. So to differentiate u partially with respect to x, we will keep y and z constant. So for the first term x square y, derivative of x square is 2x according to the formula d by dx x raised to n, that is n into x raised to n minus 1, and y is constant. Then after, if we will talk about the second term, that is y square z, and that is constant, so its derivative will be 0. Now for third term, z square is constant and derivative of x is 1. So we have del u by del x, that is 2xy plus z square. Now similarly, we will find out del u by del y. So to differentiate u partially with respect to y, we will keep x and z constant. For first term x square is constant and derivative of y with respect to y, answer is 1. Now for y square z, second term, derivative of y square, that will be 2y and z will be constant. So the answer is 2yz. Now similarly for z square x, right, z square x is constant, so its derivative will be 0. Now we will see del u by del z, right? So to differentiate u partially with respect to z, we will keep x and y constant. The first term is x square y, so its derivative will be 0. Now for second term y square z, derivative of z with respect to z, answer is 1 and y square will be same. Then after plus, third term is z square x. X is constant and derivative of z square is 2z. So we have del u by del z, that is y square plus 2zx. Now we will find out del u by del x plus del u by del y plus del u by del z. So del u by del x is 2xy plus z square plus del u by del y is x square plus 2yz plus del u by del z is y square plus 2zx. Now we will arrange these terms. So we have del u by del x plus del u by del y plus del u by del z, that is equals to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Now this is nothing but x plus y plus z the whole square according to the identity a square plus b square plus c square plus 2ab plus 2bc plus 2ca, that is equals to a plus b plus c the whole square. Now we will proceed on to second problem in this case, that is del square u by del x square plus del square u by del y square plus del square u by del z square. So we will find out first del square u by del x square. So to find out del square u by del x square, we require del u by del x, and del u by del x is 2xy plus z square. Now we will partially differentiate this del u by del x with respect to x. So keeping y and z constant. So del square u by del x square, 2y is constant, derivative of x is 1 and z square is a constant value, so its derivative will be 0. So we have del square u by del x square, that is equals to 2y. Now similarly we will find out del square u by del y square. To find out del square u by del y square, we require del u by del y, and that is x square plus 2yz. Now we will differentiate partially del u by del y with respect to y. So x square is constant, its derivative will be 0. Then after plus 2z is constant and derivative of y is 1. So del square u by del y square, answer is 2z. Now we will find out del square u by del z square. For that purpose we require del u by del z. And del u by del z is y square plus 2zx. Now we will partially differentiate del u by del z partially with respect to z. So derivative of y square, that will be 0, and then after derivative of z will be 1 and 2x is constant. So we have del square u by del z square, that is equals to 2x. Now we will find out del square u by del x square plus del square u by del y square plus del square u by del z square, and that is equals to 2y plus 2z plus 2x. Now taking 2 common, so into bracket we have x plus y plus z. So this was problem number 1. We have gone through how to find out first order and the second order partial derivatives in this problem, and then after we have obtained the result of del u by del x plus del u by del y plus del u by del z, and then after del square u by del x square plus del square u by del y square plus del square u by del z square. Okay. Now we will see example number 2. That is, if u equals to e raised to 3xyz, we have to prove that del cube u by del x del y del z, that is equals to 3 plus 27xyz plus 27x square y square z square into e raised to 3xyz. So to find out del cube u by del x del y del z, first of all we have to find out del u by del z. Then after we will differentiate partially del u by del z with respect to y, and finally the result del square u by del y del z will be differentiate partially with respect to x. Now here the function is u equals to e raised to 3xyz. So first of all we will find out the partial derivative of u with respect to z. So differentiating u partially with respect to z, so we will keep x and y as constant. Now u equals to e raised to 3xyz, so we have del u by del z. Now you know very well the derivative of e raised to x, answer is e raised to x. So derivative of u, that is e raised to 3xyz, so answer is e raised to 3xyz, but in place of x we have 3xyz. So again we will differentiate partially 3xyz with respect to z. So 3xy is constant and derivative of z is 1. So this is del u by del z, that is equals to 3xy into e raised to 3xyz. Now we will differentiate partially del u by del z with respect to y to obtain del square u by del y del z. Now we are differentiating with respect to y, so definitely we will keep x and z constant, right? So 3x is constant and we will apply the product rule on the function y into e raised to 3xyz. So e raised to 3xyz is same multiplied by derivative of y with respect to y, answer is 1. Then after plus y will be as it is and derivative of e raised to 3xyz, answer is e raised to 3xyz. And in place of x we have 3xyz. So again we will differentiate partially 3xyz with respect to y. And derivative of y is 1 and 3xz is constant. Now we will simplify this result. So taking e raised to 3xyz common and multiplying the bracket by 3x. So we have e raised to 3xyz into bracket 3x plus 9x square yz. Now this is del square u by del y del z. Now we will differentiate del square u by del y del z partially with respect to x. So we will keep y and z constant. Now here you can see we have two terms. One is e raised to 3xyz and other is 3x plus 9x square yz. Now on these two functions we will apply product rule. So that is e raised to 3xyz as it is and multiplied by derivative of bracket partially with respect to x, and that is 3 plus 18xyz. Then after plus second bracket, that is 3x plus 9x square yz is constant, multiplied by derivative of e raised to 3xyz partially with respect to x. So e raised to 3xyz will be same, multiplied by derivative of 3xyz with respect to x, and derivative of x is 1 and 3yz is constant. E raised to 3xyz into bracket we have 3 plus 18xyz, then after multiplying the bracket 3x plus 9x square yz by 3yz, so we have 9xyz plus 27x square y square into z square. Now again we have to simplify this result, so that is equals to e raised to 3xyz into bracket 3 plus 18xyz plus 9xyz, the result is 27xyz plus 27x square y square z square. So this is the required result, that is del cube u by del x del y del z, and that is equals to e raised to 3xyz into bracket 3 plus 27xyz plus 27x square y square z square. So in this lecture we have discussed higher order partial derivative, mixed derivative theorem, that is also called commutative property, and the rules for partial differentiation, and we have gone through two problems related to this topic. Thank you for watching this video. I will see you in next lecture.